lots of people call us commies and CCP lovers and et cetera, that we can't repeat for the podcast on China's quantum breakthrough that broke Google's topological new state chip. But all we do is report verified facts.
Yeah, that was something.
We just checked with the good Dr. Alan Thompson that puts out the memo paper to heads of state all over the world, and that was true, and so is this breaking news out of China again.
Right.
Today, we're diving deep into the announcement of a significant new open source AI model coming out of China. It's called Qwen.
And yeah, our exploration today, it comes from analyzing a YouTube video transcript that really detailed this announcement.
Okay.
So our mission in this deep dive, essentially, is to understand what makes Qwen noteworthy, kind of how it stacks up against the current big players, the leading AI models,
Right.
and what implications this might have for AI research going forward.
Okay, let's get into it then. Starting with the name, Qwen 235B A22B. It's quite a string of characters. What does all of that tell us?
It's actually quite informative once you break it down.
Right.
Qwen is pretty straightforward third iteration in their series.
Okay, makes sense.
Then 235B. That's the total number of parameters in their flagship model.
Parameters being the connections the model uses to learn, scale, basically.
Exactly. Think model size, complexity. Generally, more parameters can mean more capability. And 235 billion is, well, it's big.
It's definitely up there. But then we have this A22B part. What's that about? Activated parameters?
Ah, yeah, this is where it gets really interesting architecturally. They're using a mixture of experts approach MOE.
MOE, right. Heard that term.
So instead of one massive network, picture it like a collection of specialized smaller networks. These are the experts.
Okay.
And for any given question or prompt you give it, only a specific subset of these experts gets activated.
Ah.
That's the A22B. It means only 22 billion parameters are actually firing, doing the work for any single query.
Gotcha. So massive potential size, but efficient in practice because only a fraction is used each time.
Precisely. It lets you have that huge scale without the full computational hit on every single task. It's clever.
Yeah, it is like having a huge team, but only calling in the specialists you need for a specific job.
That's a great analogy.
How does that contrast with, the standard dense models we usually hear about?
Right. So in dense models, the entire network, all the parameters, they're engaged for every single input. Everything fires.
Okay.
But Qwen isn't just this big MOE model. The announcement also included 6 other models that are dense.
Oh, really?
Yeah, ranging from 32 billion parameters down to 6 billion. And crucially, these dense models, they're open-weighted.
Open-weighted, meaning the actual learned values, the core of the model, are available.
They put them out there.
Okay, so we've got this really powerful flagship MOE model and then this family of smaller, open-weighted, dense models. So how does the big one actually perform? The transcript said competitive with the top-tier AI.
Yeah, that's definitely a key takeaway. The benchmarks they shared, they really do put the Qwen flagship model right up there.
With who?
The analysis mentioned DeepSeek R1, models from Grok, Gemini 2.5 Pro, and even OpenAI's models. O3 Mini was used as a specific comparison point in the transcript.
That's some serious company. Did they run specific tests? Any standout results?
Oh, yeah. They put it through its paces. On Arena Hard, which kind of tests conversational ability, Qwen apparently landed somewhere between Gemini 2.5 Pro and O3 Mini, which is impressive.
Definitely. What else?
Then you have things like the AMI math competitions, 24 and 25. Again, very competitive, really close scores to the top models.
Okay.
But here's where it gets maybe even more interesting. Coding benchmarks. On Live Code Bench, Qwen actually beat Gemini 2.5 Pro.
Wow, okay.
And on Code Forces, it apparently beat both Gemini 2.5 Pro and O3 Mini.
Outperforming Gemini on coding. That's a significant claim.
It is. And the analysis also mentioned it did well on other unnamed tests, too. So strong performance across the board, it seems.
But the transcript also included a bit of a warning, right, about benchmarks not being the whole story.
Yes, absolutely.
Yeah.
That's always the caveat, isn't it? Benchmarks are super useful for comparisons under controlled conditions.
Right.
But they're just one piece of the puzzle. It's possible to, let's say, fine-tune a model to do really well on specific benchmarks.
Without necessarily being better overall in the real world.
Exactly. So great scores, definitely noteworthy, but you always take them with that grain of salt. Real-world usefulness is harder to measure.
Makes sense. Okay, so performance looks strong, benchmark caveats noted. But let's circle back to those other models, the dense ones being open sourced. Why is that such a big deal for the AI community?
Oh, it's huge. By releasing the model weights openly, like on Hugging Face, Model Scope, Kaggle,
Yeah.
they're essentially giving the keys to the engine, like you said earlier, to the global research community.
So researchers, developers, even companies can just grab them.
Yep, grab them, experiment, build on top of them, modify them, fine-tune them for specific needs. It really empowers innovation.
It lowers the barrier to entry, right? You
Yeah.
don't need to train a massive model from scratch yourself.
Precisely. And historically, in software, open sourcing like this tends to dramatically accelerate progress. We could see that happen here in AI too. Faster development, wider deployment.
It democratizes it in a way.
It does. And the transcript mentions something intriguing. A developer hinted at unwritten features.
Unwritten features, what does that mean?
It sounds like they believe there might be capabilities lurking within the model that even they haven't fully tapped into yet.
Hmm.
So by opening it up, they're kind of inviting the world to help discover those latent abilities, find new ways to use it, maybe stumble upon breakthroughs they didn't anticipate.
That's pretty cool. Collaborative discovery, almost.
Okay, let's dig into some specific features. This dual mode thing, thinking and non-thinking modes. Sounds
Wow.
interesting. How does that work? Yeah, it's a really clever design.
Yeah.
So the thinking mode is basically for when the model needs to, well, think hard.
Deep reasoning, problem solving.
Exactly. It allocates more computational resources, takes more time, follows steps, tries to reason things out carefully.
Okay. And the non-thinking mode.
That one prioritizes speed and efficiency.
Yeah.
It's for quick answers, tasks that don't need that deep deliberation, like, simple lookups or standard responses.
So it can switch gears depending on the task. How does that help overall?
They call it thinking budget control. It means the model can be smart about where it spends its energy, its computational budget.
Right.
More budget for the complex stuff via thinking mode, less budget, but faster responses for simpler stuff via non-thinking mode. It gives you a better balance of performance and efficiency, makes it more versatile.
And those performance charts mentioned in the transcript for AIM and the coding stuff, they showed the benefit of this, didn't they? Especially with more tokens.
They did. You could see on tasks like AIM, the thinking mode's performance clearly improved as it was given a larger token budget, basically more space to work, more room to lay out its reasoning.
So more tokens lets the thinking mode think more effectively.
Kind of, yeah. It can use that space to generate intermediate steps, explore possibilities. Meanwhile, the non-thinking mode's performance was pretty flat regardless of the token budget.
Suggesting it's just built for speed, not deep thought.
Exactly. And yeah, those improved scores on Live Code Bench and TBQA Diamond with more tokens also really highlight how the thinking mode benefits from more room for complex tasks. And just quickly, for listeners, a token is like a piece of text. The model processes could be a word, part of a word.
Got it. Okay, beyond the dual modes, what else did the transcript highlight? Lots of languages, better agents stuff.
That's right. Impressive language support. 119 languages and dialects mentioned. That's pretty broad coverage.
Yeah, definitely global reach.
And yes, improvements in agentic capabilities. Yeah, this is a big area right now. It means the model's better at, like, using tools, interacting with software, planning steps to achieve a goal autonomously.
Like it can do things, not just talk.
Sort of, yeah. It's moving in that direction. Yeah. The transcript also mentioned better support for Anthropic's Model Context Protocol, MCP.
MCP, that helps it interact with other tools more smoothly.
Basically, yeah. It's a standard way for AIs to call on external tools or APIs to get things done.
Okay, let's talk data. The fuel for these models. The training data set for Qwen 3 sounds enormous.
It really is. Qwen 2.5 was trained on, 18 trillion tokens, which is already huge. Qwen 3, over 30 trillion tokens, almost double.
Wow, where does all that data come from?
The usual suspects, mostly. Lots of web data, PDF documents, a huge variety of text.
And I thought I heard something interesting about how they got that data ready, using their older models.
Yeah, that's a fascinating bit of AI self-improvement, isn't it? They apparently used Qwen 2.5 VL, the vision language model, to actually extract text from documents. Okay. And then they used the regular Qwen 2.5 model to basically clean up and improve the quality of that extracted text.
So AI refining data for the next generation of AI.
Exactly. And not just cleaning, they also use Qwen 2.5 math encoder models to generate synthetic data.
Generate, like, fake data.
Well, synthetic examples, things like textbook explanations, question and answer pairs, code snippets, all designed to boost the quality of the training data, especially for math and coding. It shows that iterative loop models helping build better models.
That's really smart. Okay, so pre-training was huge. It was broken down into stages in the transcript.
Yes, 3 main stages described.
What was stage 1?
Stage 1 was the big data dump over 30 trillion tokens, context length of 4,000 tokens. The goal here was foundational. Basic language skills, general knowledge, just absorbing a massive amount of text.
Building the base, stage 2.
Stage 2 added another 5 trillion tokens, but with a focus. More emphasis on knowledge-heavy stuff, STEM subjects, coding, logical reasoning data, deepening the expertise.
Okay, specialized knowledge. And stage 3.
Stage 3 was all about context length, using high-quality, long-context data to push the model's ability to handle longer sequences of information, extending that context window up to 32,000 tokens.
32K tokens. That's a lot of text you can keep in mind at once.
It is. Allows for much more complex conversations and document analysis.
So that's pre-training, but then there was post-training too, right? More stages.
Yep, 4 stages of post-training to really refine its abilities.
What were they aiming for there?
Stage 1 was called Long Chain of Thought Cold Start, basically teaching it how to reason step by step, starting with just a few examples, building that fundamental reasoning skill.
Okay, teaching it how to think.
Then stage 2, reasoning reinforcement learning, using positive reinforcement, rewarding it when it gets answers right through logical steps, solidifying that reasoning.
Makes sense. Stage 3.
Stage 3 was thinking mode fusion. This is where they integrated those thinking and non-thinking modes we talked about earlier, making sure it could blend them effectively.
Getting the two modes to work together smoothly.
Exactly. And finally, stage 4 was general reinforcement learning. This was about improving its ability to follow instructions accurately and boosting those agentic capabilities further.
Polishing the final product.
Pretty much. And the end result of all this pre- and post-training, that's the flagship 235B, A22B model, and also the 32 billion parameter dense model they highlighted.
Right. We also heard about these lightweight models created through strong to weak distillation. Sounds technical.
It does, but the concept is pretty straightforward.
Sure.
Think of it like teaching. You have the big, powerful teacher model.
The flagship Qwen 3.
Right. It generates a lot of examples, like synthetic data showing how it solves problems or answers questions.
Okay.
Then you use that data generated by the strong teacher model to train smaller, less complex student models.
Ah, knowledge transfer from big to small. Why do that?
Benefits are speed and efficiency. These smaller, distilled models are much faster, need way less computing power to run.
So they could run on, like, a phone or edge devices.
Potentially. Yeah, that's the goal. Making capable AI more accessible and cheaper to deploy. The trade-off, usually, is they might not be quite as capable overall as the giant teacher model they learned from.
Right, a slight performance hit for much better efficiency. Got it. Now, drilling down a bit more on the reinforcement learning part, any interesting details there?
Well, stage 1 used that diverse, long chain of thought data to build the reasoning foundation. Stage 2 involved scaling up the compute power and using rule-based rewards.
Rule-based rewards.
Yeah, basically setting specific rules for what constitutes a good step or a good answer to guide its learning and encourage it to explore different problem-solving paths. Helps it learn to balance exploring new ideas and exploiting what works.
Okay.
And it was explicitly mentioned, interestingly, that they did not use DeepSeek's GRPO approach for this reinforcement learning part.
Okay, taking their own path there. And stage 3, integrating the non-thinking mode.
Right. They did that by fine-tuning again, using a mix of more long chain of thought data and instruction-following data that was actually generated by the already improved thinking model itself.
Using the model to teach itself again, in a way.
Exactly. Helps ensure that blend of quick responses and deeper reasoning feels natural and works well together.
So, looking towards the end of the announcement, the blog post apparently concluded with a statement about shifting focus from training models to training agents. What's the takeaway there?
Yeah, that's a really significant statement, I think. It signals where they see the field heading and where their own efforts are going.
Towards AI that can do more.
Precisely. It's less about just building models that understand and generate language, and more about building AI systems agents that can interact with the world, use tools, make decisions autonomously, and actually accomplish complex tasks.
So more active, less passive AI.
That's a good way to put it. They basically promise that their next iteration will bring big advancements here, impacting work and daily life. The video mentioned in the transcript also apparently showcased some of these improved agentic capabilities.
Sounds like the next frontier. Okay, one